morning. This presented article, Automatic Target Recognition Model Development for Fire Control System Based on Machine Learning, with others Victoria Vysotska, Romanchuk, Mariia Nazarkevych, Oleksandr Lavrut, Tetiana Lavrut, and Maksym Pysarchuk. Introduction. Today, the leading armies of the world strive to increase the capabilities of their main models of equipment and weapons by modernizing the existing fleet or developing the latest models. Automatic targets recognition unit is the ability of an algorithm of device to recognize the targets or objects based on data received from sensors, including video surveillance, for example, from unnamed aerial vehicles, such as drones, or from video recorders on combat vehicles. On the other hand, due to the increased use of yarns for reconnaissance by the enemy, the security and privacy of many critical locations might be compromised. Therefore, there are also a legitimate target for the fire control detection. The task of automatic target recognition in combat condition is complicated by several factors in the participle. Possible movement of the recognition object, the movement of the object from where the video surveils and future recognition of the target's originals, different weather conditions, different topography and landscape, including forest strips, presence of the object, the potentially not targets, lighting, potentially of object being recognition and not an enemy. Part of the recognition object is hidden behind obstacles. The observation angle for different objects is different. For yards from top to bottom, for combat vehicles, not only forward but upward for use, for example. Relevance and analysis of literature. To recent years, during the full-scale war in Ukraine, with gradual improvement of drone control technology, while remote sensing images and videos have become an important source of operational data, at the same time, equipment, combat vehicles with video recorders for video surveillance with elements of artificial intelligence and machine learning for real-time object recognition will increase the level of security of combatants with appropriate timely responses to the result of target recognition, video frame segmentation, detection of other objects, detection of moving objects, recognition objects and potential dangerous, object classification, object identification. There are two general scenarios for application of methods of detection objects by remote sensing by a drone or based in video surveillance from a car. In particular, data processing is assumed. 1. If the flight trip using stationary computers. 2. In real time during the flight ride when the on-board computer on the drone or in the car, respectively synchronization process on video data in real time. The parameters of the models must be within a central scala to meet the requirements for the operation of the embedded equipment. Once the operating conditions are met, the detection accuracy of the method should also be as high as possible. Selection and justification method and means of project implementation. The papers discussed a hybrid approach using CNN LSTM to improve the detection performance of military equipment with a moving background and different distance, as well as a tank APC BMP. The main contribution of the article. One collection of the image from open source for YouTube platforms, hybrid CN LSTM model with hyperparametric Turing using Bayes' optimization for object detection, three details analysis of the YOLO model on different ranges of images and that determination of their accuracy with a central confidence value. Experiments, result, and discussion. The YOLO pattern recognition model family was used to develop the target recognition model. This is latest version Ultralytics, popular real-time object detection in image segmentation product. YOLO Y8 come bundled with the following pre-built models: image classification models pre-trained of ImageNet database with 224 image resolution, instance segmentation control points trained on the COCO segmentation dataset with 640 image resolution. Object detection control points trained on the COCO detection dataset with 640 image resolution. The output performance at almost 105 frames per second on the GPU of the average modern laptop, while the at-large model runs at the average speed 16 frames per second. YOLO V18 used the POTOCH framework, a framework for developing deep neural network from Facebook. YOLO 8 has several advances over other tools, including more services supports the provision, a large number, a method of application, and use of model. The method used during the study of format data set, flip horizontal, rotation between, bridges between, cut out three boxes with 10% size each, bounding box blur up to 2.5 pixel, and bound box nose up to 15% of pixels. The experiments was presented on this slide, accuracy graph of the mod and MIP 50 with blue, MIP 50 for 52 95 with orange, and matrix with 100 epoch. Accuracy graph of the mod and conclusions. Target recognition is a priori in military affairs. This task is completed by the fact that it's necessary to recognition movie object of different topography and landscape create obstacles for recognition. Combat action can take place at different times of the day. Accordingly, the light angle and general light must be taken into account. It is necessary to detect the object in the video by segmentation the video frames and recognition and classify it. 100 epochs were taken to train the model. The analysis was carried according to MoMLeT&DS 50 average precision, MoMLeT&DS 52 95 precision and recall matrix. The proposed method can be used to identify objects of a military native on the recognition targets to create modern file control system of modern military equipment. Thank you very much. Um, the end. The end presented.